Okay, so I want to talk about parsing. Usually in parsing, there's some kind of a grammar that talks about what the language looks like, what kind of strings are accepted, how do you break it into different parts. Usually a grammar would contain some variable and a different number of forms, and so each variable could be, for example, an if statement looks like if followed by a condition, followed by then, followed by some statements, followed by and, or maybe followed by else, etc. And then it's typical that these rules are recursive and refer to each other, right? So you can have if a Boolean test, then something, but Boolean test itself could require another rule to explain what that means, and so on and so forth. Now, if you've taken a compiler course of programming languages and so on, and you learn all these different parsing algorithms, then I suppose you can use that. But if you don't have that knowledge, and sometimes it's a little bit hard to figure out all these grammars, if you know these things called LL and LR grammars, then you have to build tables, etc. But most of the time, for this kind of problems in programming contests, these are not actually needed. Okay, so what you typically do is you look at all these grammars, and each rule would say let's say a Boolean test looks like the following, or looks like one of the following. So what you would do is you would write a function for each variable. So you might write a function that says Boolean test, right? If somebody gives you a string, returns true or false. Is it a Boolean test or not? And inside, you would basically have code that would check each of the rules that applies to a Boolean test. And they may recursively call other things, right? Sometimes you might have multiple rules, and you might have to try multiple rules to see if any of them works. And this is basically a mutual recursion to try to break the string down into smaller and smaller chunks. Now, the way that this works, you may end up looking at the same piece of strings multiple times, depending on how these rules work, and then maybe break up a certain string and say, is this a Boolean test? And then at some other point, you look at that and you ask, is this something else? Is it an if statement? Is this? And you might look at the same string over, same substring over and over and over again, and it's not usually the most efficient, but the most efficient things are what you're learning if you take a compiler course, but they're significantly more complicated. So unless your strings are really long, usually this is fine. So one of the problems that you have to do, it's called slurpees, and basically they define three different things in the problem. One is called slurpee, one is called slump, but it's called slim. Doesn't really matter what you call them. And their rules. A slurpee is something and something or something else. A slump is something or something or something else, etc. And what you do is you write a function that you write three functions. Given a string, is it a slurpee? Given a string, is it a slump? Given a string, is it slim? And then you just call it on the top level string, a slurpee on the string itself, and then whether it returns true or false, that's your answer. I'm not going to say too much more because I already have a video that talks specifically about the slurpees problem. Another problem that it's have this parsing kind of flavor, it's number of paths. So basically you have a bunch of if then else statements. You have a kind of program that contains only straight line statements if then else. And your goal is to figure out how many different ways can your code execute. So let's actually go to the problem to make it more clear. So here's the problem. Let me make it a little bit bigger. Okay, so we'll skip through the description. So for example, here's a bare bones program. You have an if, you have an else, you have an and if. So if something is true, then you execute something in between if and else. Otherwise, you execute the else part. So depending on whether the condition is true or false, there are two ways you can execute, right? Now, so in this problem, the keyword S means a single statement. That is a straight line statement. but it could also be omitted. So if you see S, then it basically means that it's a statement that have no branching. Now, how would you have more than two paths? Well, if you have nested things, so let's look at here. So if this one is not very good. So here, for example, you have if, and then inside you have another if, then else. So here, let me try to highlight this properly. So here's the nested if then else. This if match with this else. So the two ways this code can execute. This if can be true and then you execute this part, or it can be false and then you execute the else part. Okay. But if it's true, now you're in the nested part. And inside there are two different ways you can execute. So just by looking at this, if it's true, you have two ways to execute. If it's false, you have one way. So in total, there's three ways to execute just that portion. Okay, so how do we actually tackle this? Okay. So what you can do is you can write a function, okay, that looks at the list of statements. If you see an S, you can pretty much just ignore it, okay? Because S, there's really only one path. So all the S's you can just kind of ignore. The only interesting thing is when you see an if, okay? So you see an if. Now, what you have to do, there might be other ifs, right? There might be other ifs that are nested. I know that there's no indentation in the input, but you can try to figure out the nesting level, right? Every time you see an if, you do a +1. Every time you see an else, you can do an N if, you can do a -1. So you can match the levels. And let's say that I scan through my list and I know that this if and else and N if are the ones matching, and there might be stuff inside that are nested. Okay, there could be more if statement inside. So what do I know? I can then, once I figure this out, that these are the matching if, else, and N if, I can recursively ask, how many paths are there here? Let's call it N1. How many paths are there in here? Let's call it N2. And then this structure in total would have N1 plus N2 paths. Okay. Base case, of course, is if you have an empty chunk of code, or if you just have S's. In that case, the number of paths is just one. That's almost all there is to it, except for one extra thing. If you have a chunk of if then else here, I'll just write an if here, and if, okay, so you have one chunk here, and let's say that you have N1 paths, okay, so you figure this out. And then later on, you have another if statements that are not nested, okay, so these are not nested if then else statements, and you have N2 paths. When that happens, you have N1 paths. You can take any of the N1 paths in the first part. Coming out, you can take any of the N2 paths in the second part. So altogether, the total number of paths is actually N1 times N2. So with these two parts, with these two things, it's actually relatively straightforward to do. So what you can do actually, if you have a list of if then else, right? So you always try, whenever you have a list of statements, you always say if it's S, if it's just S, you just return 1. That's nothing to do. So the first interesting thing must be that you see an if. Okay, and then you figure out the matching else, and you figure out the matching and if. recursively figure out the number of paths in the if part and the else part. Some of that could be 1, and that means that this whole box has n1 plus n2 paths. But that might not be the end of the story, because you might have other things that comes after the if, else, and if part. So you recursively ask what is the number of paths in the remainder part. That could be n3. And then you basically take this, multiply with this, and that's your answer.